Good morning to Dr. Okay, so today I am going to present about the experiment 2, which is the separation and purification of polymer. Okay, so this is the content that I want to present. Okay, so we take a look at the study objectives. Okay, first objective is to apply the separation and purification method of polymer quantitatively. And second one is to determine the percentage of cinnamic acid present in the polymer using the UV analysis. After the experiment is done, this is the result, which is the weight of the polymer or the mass of polymer for the first and the second purification. Okay, so we are going to take a look at the UV spectrum peak report under result analysis. So this UV spectrum is the UV spectrum of the solution in the range of 3 to 200 nanometer. Okay, so based on this spectrum peak report for polymer 1 or purification 1, so there's a big peak at range of 270, and for the second polymer, which is the second purification, is the big peak is about 272.2, which take the absorbance 0.317. So this is the difference between the two UV analysis respective to the polymer. We are going to take a look at the calculation involved the experiment. So what are we going to take a look is, we are going to take a look the percentage of cinnamic acid in polymer 1 and polymer 2, and we will use the Beer's law. So for this experiment, I have provided sample 20, which is the PMMA or polymethyl methachloride. Okay, so first we are going to calculate the molecular weight of the cinnamic acid and the polymer itself, and we are going to derive this into the formula itself. So polymer 1, we got 1.11% of cinnamic acid percentage, and for polymer 2, after doing the same equation solution, we got 0.26%. Okay, so I think there is a difference between these two, and we are going to take a look why in the discussion session. Okay, so we take a look at the discussion in this experiment. Okay, for this experiment, polymethyl methachloride or PMMA that we use as a sample is contaminated with cinnamic acid, and we are going to take a look at the percentage of the cinnamic acid present in both polymer 1 and polymer 2. So the different percentage between these two polymers is due to the effectiveness of purification method used in the experiment, because we use the same polymer and we run it to purification 2 times. Okay, so the solvent that is used in this experiment also play a major key to purify the polymer from any contamination. And for this experiment, methanol is used as a solvent for the polymer or PMMA, because methanol dissolves PMMA almost twice as fast rather than ethanol and hexanol at about the same rate. So we know that methanol is quite faster in terms of dissolving the PMMA itself rather than other solvent. Okay, for the crystallization such as double hydrophobic copolymer, the use of boron toxicity methanol solvent mixture is unquestionably preferred to the what they use organic solvent. So we can say that methanol is actually one of the most common solvents of the polymer itself. So for the UV spectroscopy analysis part, the PMMA molecule can be detected at about 200 to 270 nanometer for both first and second purification. This is because we use the same polymer, which means we will get the same range of the peak, or maybe about the same range. Okay, so UV visible spectroscopy is commonly used to obtain the absorbance spectra of the compound in solution or in solid. So in this experiment, the polymer is in solid form, but it is being dissolved with the acetone to make a solution, and the purpose is to make sure that the result is more reliable. Okay, for the UV analysis, there is a strong absorption happen in about 270 nanometers. This strong absorption edge is produced due to electronic excitation within the carbonyl chromophores, or the CO present in the PMMA structure. Other than that, it is discovered that the pi transition in the CO system is cause of the most powerful absorption band seen in the spectra between 200 and 250 nanometer. So this is the reason why there is a big peak in the range that I've mentioned before. So this characteristic are present in both type of sample. Okay, from this UV, the cinnamic acid is also present at the wavelength at about 270 nanometer, which confirm the presence of it in the compound. So we need to get the UV spectrum of the solution in the range of 300 to 200 nanometer. If there is absorbent value obtained in the peak of the wavelength outside the range, that means that there is a non-foreign object present. So in other words, that if there is a wavelength detected outside the range, then there must be another contaminated compound that has been detected by the UV spectroscopy. Okay, so which is most likely because of the error while doing or conduct the experiment. So for the conclusion, the percentage of cinnamic acid detected in polymer 1 and polymer 2 or in purification 1 and purification 2 are 1.11% and 0.26 respectively. Okay, so we move to the question part. So the question is, please suggest different types of solvent that can be used to replace methanol and chloroform in this experiment. Explain your answer. Okay, so in my opinion, acetone is another type of solvent that may work to replace methanol because it is a polar solvent. Plus, there is strong interaction in terms of intermolecular forces between acetone and PMMA. It may result in the formation of porous particles. Other solvent that can replace chloroform is toluene and acetone itself. So that's all for me. Thank you for listening.